Hi, this is Mr. Max with Sun Golfer Mathematics. So I have here three more questions on geometric progressions and sum to infinity, some practical problems. The first question here says, in a geometrical sequence, the sum to infinity is equal to 3 halves, and the sum of the first three terms is equal to 14 over 9. Calculate the first three terms of the sequence. The second question here, the first three terms of an arithmetic progression are 4, x and y respectively. The first three terms of a geometric progression are x, y and 18 respectively. It is given then x and y are positive, very important. Part A, find the value of x and the value of y. Part B, find the fourth term of each progression. So this is a very interesting question. It has an arithmetic part as well as a geometric part. And also, it exclusively tells you that the value of x and y are positive. So in your calculation, if you have to come across some negative value, you will reject that particular negative value and only focus on the positive value, either of x and y, to get the respective positive values of the other. Then question 3, the sixth term of a geometric progression is 486 and the third term is 18. So this involves you to create simultaneous equation because you're supposed to find for part A the common ratio as well as the first term. So that is an A and an R, so two letters, meaning you are supposed to come up with two equations and then you solve them simultaneously. And once you have the value of A, which is your first term, and the value of R, which is your constant ratio, then you should be able to find the first three terms of the sequence. So you can pause the video right here and then you can attempt to do these questions and see how far you get. Right, so let's get right into it. The first question, you see that I have bolded where it says calculate the first three terms, right? Very important that you understand that. But then you will realize that sum to infinity, as you know, the sum to infinity formula is a upon 1 minus r. In this case, we are told that it's equal to 3 upon 2. And the sum for the three terms, s sub n, takes this formula a in brackets 1 minus 3 raised to the power of r upon 1 minus r, which in this case is equal to 14 over 9. And our n is 3. So we are going to try to solve these two equations simultaneously by dividing the second one by the first. Either way, you would get the same result. Right, so I'm just writing them in this way. So you see that I've used this light blue in order to differentiate the sum to infinity. And you can see that there's something very interesting about writing the s sub n formula this way, not r minus 1, but in this way, such that your sum to infinity formula, which is 1 minus r, that somehow they will definitely cancel the 1 minus r. And dividing by a number is the same as multiplying by its inverse. And then also the a's cancel, leaving you with 1 minus r cubed equals 28 over 27, which you get from multiplying 14 times 2 and 9 times 3 respectively. Subtracting both sides by 1, that gives you 1 over 27. So you have got a negative value here. So I'm going to divide throughout by negative 1. And then I'm going to find the cube root of a negative number, which exists. It's only when you find the root of an even number, then the negative value does not exist. Good. So that gives me that the value of r is nothing but negative 1/3. So now that I have the value of r, I can then find the value of a by substituting either the r value into this first equation or the second equation. And you agree with me that it's better if you substitute it in the first equation. So once I do that, it just involves some basic arithmetic until you arrive at a point where you should realize that the value of a is nothing but equal to 2. So I try to show you step by step when you are dividing by a fraction is the same as multiplying by its inverse, and then getting rid of that, multiply again by its inverse. Whatever you do, you should get arrived at the value of a is equal to 2. So I have my r value and I have my a value. But the question asks me to find the first three terms. So the first term, it's 2 times that negative 1/3 is going to give me negative 2/3, which is the second term. Multiply that again by negative 1/3, that gives you 2/9. So the first term is 2, the second term is negative 2/3, and the third term is 2/9. And you see that once you write this sequence down, the signs will alternate. So because of the ratio being a negative value. So you're going to have a positive term, a negative term, a positive term, and a negative term, and so on. Right, so the second question, the first three terms of an AP are 4, x, and y respectively. The first three terms of a GP are x, y, and 18. So first I'm going to do the arithmetic progression, and I know that when you subtract the second term from the first term, you should get the same result as subtracting the third term from the second term. So I've indicated it here, and what I did, I just made y the subject of the formula so that I can definitely use this into my second equation. So when I bring in a geometric progression, you find the common ratio by dividing subsets of terms. That means term 2 divided by term 1 should equal to term 3 divided by term 2. So when you do that, you're going to arrive at y over x is equal to 18 over y, which you can cross multiply sort of, and you should get y squared is equal to 18. So now I'm going to substitute part 1 for y into part 2. That's going to give me that 2x minus 4, that quantity squared should equal to 18x, right? So once you clean up that binomial there, you get 4x squared minus 16x plus 16, and everything should equal to 0, of course, and you should arrive at 4x squared minus 34x plus 16 equals to 0. So from here, you should be able to solve this quadratic equation using whatever method. All right, so I'm just simplifying it a bit by reducing it or by dividing it by 2. So I get 2x squared minus 17x plus 8. Using the formula, you should arrive at two values. One value x is equal to 8 and one value x is equal to 1/2. Now the question says that x and y should be positive. Looking at this particular answer, you realize that x values are both positive. But in order for you to see whether you have to discard one or reject one or the other, it's best if you substitute in the formula y equals to 2x minus 4 to see what will be the subsequent values of y. Supposedly you choose x to be a half, and once you choose x to be a half, y becomes negative 3. And because y is negative 3, we cannot accept negative 3 as an answer, and we also cannot accept the value of x, which is 1/2. So I'm going to reject that particular part. Checking for 8, if you substitute, you get a positive value of y. So y equals to 12 when x is equal to 8. Therefore, that is the value that we are looking for in this particular case. So we are now supposed to find the fourth term. So we know what x is and y is equal to. So when it's an AP, it's going to be 4x and y, which would now be replaced by 4, 8, 12, and so on and so on. You should realize that the first term is a, and the common difference, which is 4, and the first term is also 4. Right, so in order for us to find the fourth term, we substitute in our T sub n formula, that's the fourth term, and should get a value of 16. When it's a geometric progression, x is 8, y is 12, and then 18, and so on. So here we have a first term as well as a common ratio, and the common ratio is 3/2. Now we can use T sub n of the geometric progression, so be very careful that you don't mix the formula around. Substituting in there, you should get that the fourth term is equal to 27. Right, so we have this question here. The sixth term of a GP is 486 and the third term is 18. So I'm going to write the sixth term first. Now I know that the formula is AR 6 minus 1. So that simplifies to AR to the fifth power is equal to 486. So that would be my first equation. My second equation, where the third term is equal to 18, that is AR3 minus 1, so that's AR squared is equal to 18. So now I have two equations here which I'm going to solve by dividing. So either divide 1 by 2 or 2 by 1, irrespective. So once I put term 1 divided by term 2, I realize that the a's cancel and 18 goes in 486 times. And then when you are dividing, you subtract the indices. That gives you the value of r cubed equals 27. And to find r on its own, you take the cube root of 27, which happens to be 3. Now that you have the value of r, you need to find the value of a. Then I substitute my value of a into the second equation. It doesn't matter which equation you use. So that gives you 9a is equal to 18, and therefore obviously the value of a will equal to 2. Now you have your r value as well as your a value. So you should be able to find the first three terms. So this part here answers the first part of the question. So to find the first three terms, you simply take the first term, which happens to be 2, multiply it by 3 to get the next term, which is 6, multiply that term by 3 to get 18. So the sequence is 2, 6, 18, and so on. Don't forget to subscribe to my videos and my channel so that you can find notifications and also assistance on any topic that you want. There are plenty plus videos there. So hit the bell to get a notification and subscribe to the channel.